Hi folks, today's lesson is on probability models, and that's lesson 13.5 in your textbook. So let's get started. Our first example has a two-way frequency table, and when it's a two-way frequency table, that means there's two different sets of information that's recorded on this frequency table. In this example, our rows are broken down by gender, and our columns are broken down by extracurricular activities, whether or not they're involved. And you'll notice that the margins are the totals. So it says that this information is information about student involvement in extracurriculars at a local high school. And we want to know what is the probability that a randomly chosen student is a female who is not involved in extracurricular activities. So the female column is this female row is this middle row here, and the not involved is the second column. So the group of people that fit both of those characteristics, both female and not involved, would be this 120. And since it's a probability, we want to know that out of the total population. So our answer would be 120 out of the 516, which is approximately 0.233. Our next example is another two-way frequency table. In this case, we have the ages of the respondents in the rows, and then across the top, the columns are labeled whether or not they are for, against, or they have no opinion on a particular bill that's being voted on. So the question is, what is the probability that a randomly selected person is over 60 years old, given that the person has no opinion on the state bill? And the words given that are important words. That means that we're only considering that group of people. We're given that they had no opinion means we're only considering this column of people here. So out of this 100 people, not out of the total 1,000 people in the total group. Well, the group of people that are over 60 is the bottom row here, this 40. Out of given that they had no opinion, out of the 100 people that had no opinion. So our answer here is our 40 over 100, or 40%, or in terms of a decimal, that would just be 0.4. Another example, we're going to use what's called a relative frequency. So a relative frequency table is everything is broken down in terms of their relative numbers. So it's a two-way frequency table. So we have rows labeled, in this case, by increase in sales or not increase in sales. And then the columns are labeled by whether or not they attended this particular seminar. And for example, this 0.48 here, that's 48% of the people are in this particular category. They increased and attended the seminar. 32% didn't increase in sales, but they attended the seminar, for a total of 80% of the people attended the seminar. And 20% of the people didn't attend. So it's broken down into a little more detail. It's called a relative frequency table. So we have 150 sales representatives, and the company vice president made this table, and he wants to know what is the probability that someone who attended the seminar had an increase in sales. So they're interested in whether or not attending the seminar had an impact on their increase in sales. And the wording is a little bit more complicated in this problem, because we want to know what is the probability that someone who attended the seminar, so we're only considering the people who attended the seminar. So this is kind of a given that problem, even though the words given that aren't in the wording. If we can reword this as a given that problem, then we can see that it's really the same problem as the previous. So what's the probability that someone who attended the seminar, so we're only considering this column of people. We only want to know this 80%, out of this 80%. What's the probability that they attended the seminar and had an increase in sales? So the group of people with an increase in sales was 48%, and now only out of the 80% that attended the seminar. So our answer would be 0.48 out of 0.8, which is 0.643. 60%. So what we're using is this conditional probability formula, and this is the notation is a little bit different. So it says for any two events, A and B, the probability of B occurring given that event A has occurred can be written this way. And this is the way we would say it. The probability of B given that A, that long bar there, we say given that. So the probability of B occurring given that A has occurred is equal to the probability of both A and B over the probability of A. And obviously the probability of A can't be 0 because we'd then be dividing by 0, and we can't express that. Hope this helps. Ask your teacher lots of questions. Good luck.